Okay, good afternoon. I think we're live. It's so long since I've done this. Yes, I can see myself on the computer. Oh, the joys of trying to get the phone propped up and not falling over is it's all coming back to me from however many weeks ago. Welcome back to Mass Life. Thank you for joining me. The t-shirt has re-emerged in the wardrobe, and even though it's a bit chillier now than over the summer. I hope you're all okay. Thank you for joining in. Thank you for those of you who are returning. Thank you to those of you who are new, and happy half term. I hope you're all okay. So the first question, just to warm up, is what are the properties of a rectangle? And if you're not sure what I mean by properties, it's what facts can you tell me about a rectangle? And it can be anything. So imagine if an alien lands on the planet Earth and you are explaining what a rectangle is, what would you say? While you have a go at that, I'm just going to do some shout outs, okay? So I'll be back in a minute. Here we go. Hello, Holly. Hello, Holly. Thank you for dropping in. As you'll know, if people are not sure what I'm talking about, English with Holly, I bet all you were like, oh no, I know who you're talking about now. Hello, Holly. Thank you for saying hi. Hi, Freya. Hello. Hi, Harry in Nottingham. Welcome back. Hello, Amelia. We've got two Amelias. So many Amelias. Sophia in Sussex. Hello, Iona. Welcome back. Welcome back. Hello, Madison and Sadie here. Oh, Sadie's only 8 years old. Welcome, Sadie. Brilliant. Oh, some people telling me some great descriptions of rectangles. Hello, Panavi from Dagenham. Hello, all the way down in London town. Okay. Brilliant. I've got a new computer as well, so I'm trying to navigate the comments and the shout outs. Forgive me if I'm a bit slow. If I don't give you a shout out, please say again, like repeat it to me. If I do, then excellent. I want to say hello to Ava as well. Ava I work with outside of Mass Live, so I hope you're okay, Ava. Okay. So if you're new, then what I tend to do is we do a warm-up challenge, and then I'll start talking through the objective for today's lesson. We do have 3 questions that we tackle, but I'm going to do it a bit differently today. And then I'll give you some challenges to have a go at. Obviously, I'll go through the answers with you because that's part of the teaching process. Today's lesson is going to be split into 2 parts. I'm going to keep it nice and snappy because, number one, I only have about half an hour. But obviously, it's your half term. You want to learn something, but you don't want to be at school. So it's like a nice balance of both. So what are the properties of a rectangle? So in your head, you're like, right, I know what a rectangle looks like. Okay. So 4 sides. That's a really obvious one. It's got 4 sides. Now, you might know other 4-sided shapes. So what makes a rectangle different from other 4-sided shapes? Well, you've got 2 sides that are the same length. And then the other 2 sides are the same length as well. So you've got 2 sides here that are the same length and 2 sides on top and bottom. Oh, speaking about the top and the bottom and how they relate to each other, I don't know if you've ever seen this before. This means that these lines here are parallel to each other. So the top line and the bottom line are parallel to each other. So there's 2 pairs of parallel lines. If they're parallel, that means they're never going to touch. So these lines here are going to go on forever and they're never ever going to touch. An example in real life, like train tracks. You want train tracks to stay the same distance apart because if a train track starts to come in, then the wheels of the train aren't going to stay on the track and something bad's going to happen. You don't want them again to extend out, because so you want train tracks to be exactly parallel. Okay, so they've got two pairs of parallel sides, never touch. Okay, if you're good at angles, if you're working at angles at school, you might spot that the corners, there's 4 right angles. Okay, and obviously there's 4 corners where the right angles are. There are so many. There are so many. Those are the main ones, but if you've thought of any others, let's just have a look at some of the comments. Brilliant. Oh, some people have even compared them to other shapes, saying unlike a square, unlike this. That's really, really good. Okay, today's lesson. The whole of this week we're going to look at fractions. Now, if you've been working with me before, I must say, you might think, Steph, we've already done this topic. You've already taught me about how to compare fractions and add fractions and subtract fractions. And you are correct. If you go back in my videos, I think it's about week 6 for when we did the lockdown learning, I have done this week. But it's always great to refresh. It's great to do a lesson from the beginning, especially when a lot of you will be doing fractions this before Christmas. I guarantee you'll be doing fractions before Christmas at school. It'll be coming up in the next half term. It's good either to learn from the beginning or to revise if you've already been taught it. So fractions all this week. Today we're going to start with equivalent. I can never spell it. See, this is where you need Holly joining in. Equivalent. Equivalent and comparing. So we're going to be looking at equivalent and comparing fractions. They do sound similar. So equivalent means like equal. And comparing is when we're sort of, is it that, like that? You're sort of not sure of the relationship between the two. They are closely linked, but at the same time they're different. And we're looking at those types of fractions. So, equivalent fractions. If you have a pair of equivalent fractions, that means they are the same. And you could have one fraction and there are endless ways that you can make the same fraction. One obvious one I'm going to start with is half. Okay. And the tradition is when you're talking about fractions, you tend to use pizzas quite a lot, and I say chocolate bars. Okay, I know it's not the healthiest thing, but it's one of the more delicious terms to use in maths. So if you're talking about half, you know that that means for every one thing, you split it into 2 parts. Okay, so for example, in this pizza, there is one part there and one part there. That whole part, that whole pizza has been split into 2, 1 out of 2. But you might have a really big pizza and there's more than 2 of you sharing the pizza. There might be 4 of you. Okay, but what if it was the same amount that was shaded? Do you see on the first pizza how I split it in half and I shaded like that? Can you see that the same proportion, the same amount is still shaded? But the fraction isn't the same. If you've done fractions of shapes, you will know that the whole thing, there's 4 parts in total, and how many of those 4 parts have been shaded? 2. So that means that 1/2 is the same as 2/4. They are equivalent fractions. They are the same. And do you notice that 2 is half of 4? Just like 1 is half of 2. Can we think of any other fractions where the top number is half of the bottom number? Okay. What about 6? What's half of 6? 3. What about 8? What is half of 8? 4. These are all good, and it can go on forever. 1,000 over 2,000. 500,000 over 1,000,000. It's the same, and they're endless. So that's what equivalent fractions mean. It's when they are the same. Where's mine? I should have got a new board rubber, shouldn't I? All this time that I've not been here, I should have got a new board rubber. My trusted board rubber. So here's some examples. For those of you thinking, Steph, you haven't mentioned the 3 questions. I'm going to come back to that gradually. You might have noticed that some of them are quite tricky, so I'll come back to the 3 questions. So, for example, 3/5. 3/5. And I'm going to tell you that I'm going to compare it with a denominator that ends in 10. Okay? So, for example, if I've got a chocolate bar, it's the same chocolate bar. You can see that these 2 chocolate bars, they're joined together and they're the same space. It takes up the same amount of space. I'm going to split this one into 5 equal parts. But the bottom one, I'm going to split into 10. Ooh. Okay, trying to make it as accurate as possible. I've tried to be as accurate as possible. So the same chocolate bar has been just, all it's done is been snapped into more pieces. The top one is the 3/5. So 1, 2, 3. Now how many pieces of that chocolate bar are equivalent with 10? This is the 10. So 1, 2, 3, 4, 5. Can you see that that is the same point? They meet at the same point. So how many pieces in the tens make the same as 3? 1, 2, 3, 4, 5, 6. So 6 over 10 is the same as 3 over 5. But it's not an art lesson, okay? It's a maths lesson. I'm not going to make you throughout this lesson draw pizzas or chocolate bars. I mean, go ahead if you want to, but it'll take you quite a lot of time. By the time you're in year 6, you don't have the time to do that. Notice, can you see that 5, if you double it, if you times it by 2, it makes 10. Oh look, so if you do the same to the top, if you double 3, that makes 6. So that's how you make them equivalent. Let's try now with 1, where we don't have to draw anything. What about 1/4? I'm asked, how is a quarter equivalent to a fraction that is out of 8? Okay, well, what's the relationship between 4 and 8? Can I change 4 using multiplication or division? Remember, multiplication and division with fractions when changing them. Well, if I double 4, that makes 8. And whatever you do to the bottom of a fraction, you do to the top. So if I times that by 2 as well, 1/4 is the same as 2 over 8. So I'm balancing the fractions. One more. 4 over 6. What if the fraction that I'm making equivalent to is over 3? Now, what is the relationship between 6 and 3? You might notice that if you times 3 by 2, it makes 6. But I don't know what's on top. Do you also notice that if you split 6 in half, you divide it by 2, that makes 3. So let's divide 4 by 2. Let's split 4 in half. What is half of 4? 2. So 4 over 6 is the same as 2 over 3. Now, in those 3 challenge questions, question 1 was 2/5 is what over 10. So do you notice if you times 5 by 2, if you double 5, it makes 10. So do the same to the top. That is 4 over 10. Anyway, less talking for me. I know that was quite quick me showing you, but you have a go, and that's the best way for you to learn is to practice. So here are your first 3 challenge questions for this lesson. Right, pen and paper ready. What is 1/3 equivalent to when the denominator is 16? Ooh. What is half equivalent to when the denominator is 8? And what is 10 over 25 equivalent to when the denominator is 5? Give that a go while I have a look and see all the wonderful people that are taking part in this lesson. Wow! Look at all the comments. I need to scroll back so far. Amazing. I love all your descriptions of the rectangle. Hi Xavier. Thank you for joining in. Hi Breeze, welcome back. Hello Olivia. Brilliant. Fantastic. Hello Malik in Bahrain. Amazing. Thank you for tuning in all the way across in Bahrain. Hi Seren in London. Hi Toby. Thank you for joining in. You lot are so clever. You really are. Even Harry's like, what? Fantastic. Oh, yes, you lot are on fire already this morning. I'm going to do it the opposite way. Okay. And I'm sure all of you realise why. Now, 25 to 5. 25 is in the 5 times table. Okay, so there is a direct relationship between them. If I divide 25 by 5, that gives me 5. So do the same to the top. How many 5s are in 10? 2. So it's 2/5. Okay, 2/5 is the same as 10 over 25. It looks like I know it looks strange. Like, how can 10/5 be the same as 2/5? But they're just balanced. Okay. So if you times 5 by 5, that makes 25. If you times 2 by 5, that makes 10. A half. So what's the relationship between 2 and 8? How do I change 2 so that it becomes 8? Times it by 4. Do the same to the top. 1 4 is 4. Now I was mean for the first one, but well done for spotting. You can't actually change 3 into 16. 16 is not in the 3 times table, so we can't actually make it equivalent, okay? You'll see in the next part of the lesson how we can compare them, but we can't make them equivalent. So what I'm going to be doing, I'm going to be nice. I am going to make them equivalent. I'm so proud of you all for spotting. What if we made it into 50? What if we made it 1 less? Tell someone next to you, say it out loud. What if it was 1/3 and it's an equivalent fraction which has got 15? What would you do? Say it out loud. So what do we times 3 by to make 15? 5. Do the same to the top. 1 times 5. So 1/3 is equivalent to 5 over 15. Fantastic. Now another question I put in the 3 warm-up questions, just to clarify, the 3 warm-up questions, each morning this week at 10 o'clock I will post 3 challenge questions on my page. Harry's like, I'm an expert at this. I know exactly what you're talking about, Steph. The 3 challenge questions, 10 o'clock. You can do them at 10 o'clock. You can do them at 12 o'clock. You can do them 3 minutes before this lesson starts. It's just to get your brain warmed up and thinking about what this lesson is about. We already did question 1, which is what was 2/5 if the denominator is 10. The second question is, how else can you write 1/4? Now, remember when I taught you about a half and how you can keep going forever and ever and ever and ever with a half? Can you give me 3 other ways that you could write a quarter? What other fractions are equivalent to 1/4? Have a go at that. Brilliant. 5 over 15, you fab lots. You know what? And I'm really pleased that you all said, like, Steph, it doesn't work. Steph, it doesn't make sense. Steph, you can't do question 1. That's really, really good. Oh, some people are doing some proper, like, some proper challenge questions. Amazing. I love that. Some people, I'm not going to just do the boring fraction. I'm going to go right up there. So a quarter. So it's like, what fractions are the same as a quarter? Now if I double it, if I times by 2, that's 8. So do the same to the top. That's 2 over 8. Basically, the top number is a quarter of the bottom number. So 4 divided by 4 is 1. So if we went all the way to 40, that would be 10. If we went all the way to 400, that would be 100. If we went to, say, I don't know, 20, what do you times 4 by to make 20? 5. So you do the same to the top, so it'd be 5 over 20. As long as the top number is a quarter of the number at the bottom, so if you times the number at the top by 4, it should make the number at the bottom. So there's a million ways that you can write a quarter as a different fraction. Okay, that's already part 1 of the lesson done. Part 2, comparing fractions. This is when there is, like, you know when I did the 1/3 and something over 16, this is when you need to use this part of the lesson, okay? Because this is when you can't see a link between the two, either the two denominators. You're like, well, that isn't a factor of that, it's not in its times table. So if I give you an example, you might get a question is, which is bigger? Which is bigger? So you might use your bigger, smaller than, equal to. Which is bigger? 1/3 or 2/5? Which is bigger? 1/3 or 2/5? And you're like, okay. 5 is not in the 3 times table, and vice versa. And how do you do this? I can't times 3 by anything to make it into 5. So you can't do, you can't make it, we're not looking at equivalence, we're not looking at them being the same, we're comparing them. When you compare something, it's like, if it's bigger or smaller than, or longer than, or shorter than, okay, or, you know, cost more, cost less. So what we need to do, because we can't make the denominators the same by converting them in times tables, we need to do a different way of making them the same. The easiest, I think, way to do it without going into factors is if you multiply the denominators, okay, it will give you a new denominator. 3 times 5 is 15. Okay, just checking it's still on the board. Okay, so 15 is in the 3 times table, and 15 is in the 5 times table. So we can use this to help us. But you need to balance them. So how do you change the factor 1/3 so the denominator is 15? You're now making these equivalent. So what did you times 3 by to make it into 15? 3, 6, 9, 12, 15. So you times it by 5. You times it by the opposite number. So we do the same to the top. 1 times 5 is 5. Right. What did you times 5 by to make it into 15? Well, you times it by the opposite number. 5, 10, 15. Do the same for the top. 2 times 3 is 6. Which is the bigger fraction? 6 over 15 is bigger than 5 over 15. So 2 over 5 is bigger than 1/3. Okay, I'll show you another example. Because I know that's a lot more steps than just doing equivalent fractions, but can you see how you need to use equivalent fraction skills to be able to compare fractions? 3/4 or 4/6. I'm always going to try and use fractions that are close to each other. There's no point me saying 1/8 or 9/10 because you know 9/10 is bigger than 1/8. So I always try and use fractions that are quite close. Again, 4 and 6, they're not in each of the times tables. So let's multiply the denominators. Okay, 4 6s, 24. Right, they're both now over 24. Okay, what do you times 4 by to make 24? Well, 6 4s are 24, so it must have been by 6. Do the same to the top. 3 times 6, 3 6s are 18. What did you times 6 by to make 24? How would you make 4/6 into an equivalent fraction so that 24 is the denominator? 6 times 4 is 24. Do the same to the top. 4 times 4, 16. 18/24 is bigger than 16/24, so that this time, okay, the crocodile is eating the biggest number, which is 3/4, 3/4. One more, and then it's your turn. Okay. 8/10 or 2/3, which is the biggest. You might even be asked which is the smallest fraction. Right, again, 10 and 3, they don't really link, you can't make them together. So what we're going to do is multiply them. So I always change pen colour just to try and make the steps different. Right, 10 times 3 is 30. Doesn't matter how big the number goes, as long as the comparison is equal. What do you times 10 by to make 30? 3. Do the same to the top. 8 3s. 1 8 is 8, 2 8 is 16, 3 8 is 24. Right, what do you times 3 by to make it into 30? Times it by 10. Do the same to the top. 2 times 10 is 20. Which is bigger, 20/30 or 24/30? 24/30 is bigger. So the crocodile is going to eat that fraction. Right, it's your turn. I know this is tricky, especially if you're joining me and you're in year 3 or year 4, or even obviously you're just starting year 5. Year 6s, this should be revision for you, but obviously you're giving it a good go as well. Here we go. 3 questions. And it's lovely that you're joining in and you're shouting out, so that's really, really good. Your first question is 1/6 or, so I'm looking for which one is the biggest. 3/10. Question 2 is 4/5 or 7/9 and 5/12 or 3/8. And can you see why drawing the pizzas or chocolate bars is a little bit tricky if you're getting onto these types of questions? This is why we move away from pizzas and chocolate bars. Let's see who's taking part. Wow, the participation is amazing. I'm having to scroll back so far. Yes, greater than and less than. Absolutely. Brilliant. I love it. I love it when you actually talk about it while I'm doing it. Even though I'm modelling it, guys, I love that you actually say, oh, I think it's this. Yeah? Oh, I was correct the first. Oh, it's fine. Don't worry if you were correct the first time and then you sort of doubt yourself. At least you knew. Have confidence. It's fine if you got it wrong. Don't worry. Don't worry. Super.
I've got Sarah Khan. Hello, Sarah. Thank you for joining in. My teacher calls them the top of a Toblerone. That's an interesting one. I've never heard that. The top of a Toblerone. I like the crocodile. Crocodile eats the biggest number. And what I really like about you guys joining in is that, you know, at school when the teacher's talking and they're modelling it to you, you really need to have your pens down and folding your arms and sitting and watching. You don't have to with this lesson. You can sort of have a go while I'm teaching to you. So it's really, really nice. But obviously at school, please listen to your actual teacher and do what your actual teacher expects you to do. So, I know some of you are still finishing. Let me just look at some of the answers. Yeah, although I like that. It's, yeah, fractions. Oh, it's such a big topic, and I know it can be really intimidating. Like, oh, I don't like fractions. But hopefully, this week I can make it a little bit more clearer to you. That's the purpose of me doing Maths Live. That's why I'm here at lunchtime during half term. It's, you know, I just want to help you guys, so I hope I can make fractions a little bit more understandable. Right, 1/6 or 3/10. Okay, so I need a bit of space. I'm going to use this side of the board. So I need to multiply the denominators. 6 times 10 is 60. Now, what did I do to 6 to make it 60? Times it by 10. So 1 times 10 is 10. What did I do to 10 to make it 60? I times it by 6. 10 times 6 is 60. Do the same to the top. 3 6s are 18. Therefore, 3/10 is bigger than 1/6. Well done if you got that right. And if you didn't get it right, it doesn't matter because you're learning. Yeah, you're learning. What's the worst that's going to happen if you get the answer wrong? In a fun lesson, okay? 4/5 or 7/9. Okay, so let's times it together. 9 5s, 45. Okay, what did you times 5 by to make 45? Times it by 9. Do the same to the top. 4 9s, 36. Oh, these are big fractions. What did you times 9 by to make 45? Times it by 5. 7 5s, 35. Oh, look how close. This one just wins. 36 over 45 to 35 over 45. So 4/5 is bigger than 7/9. I made that question up completely off the top of my head, so that was a nice close one. And the last question, 5 over 12 or 3 over 8. Oops, 8 does not have a 1 there. Okay, so 12/8. You know what, I was just thinking then. I've not had a moment yet, and I always do. If you're new to my lessons, I always have a moment where I have a brain freeze or I make a mistake. And just at that moment, I was like, I've not had one yet, yay! And then lo and behold, it always happens. 12/8 are 96. Oh, I'm all thrown off now. 96, okay. You'll be all like, it's not 96, but I'm just going to carry on anyway. Times by 8, 12/8, 5/8 are 40. Okay, and then what do you times 8 by to make 12? I've got the giggles now. 1 12, 2 12 are 36. Can you see that 40 is bigger than 36, therefore 5 12s is bigger than 3 over 8. Let me just see how you all got along. How did you do? Fantastic. Amazing. Oh, well done. Fantastic. Fantastic. Well done. Right.
It's 2:05. I think we'll call that the end of the lesson. So that's equivalent and comparing fractions. Like I say, I think week 6 of the initial lockdown, the same lesson will be on this if you want to have a practice. I obviously will put a challenge task on the page after this lesson's finished, so it can be like homework to take away. Tomorrow we're going to be doing mixed and improper fractions. So what happens if you have a whole number and a fraction and you need to combine that whole number and that fraction into one fraction and you mash them together? What do you do? I will explain it tomorrow. Thank you so much for joining and I hope we get to see you tomorrow. Bye bye.